What's up everyone, and welcome to the first section of our Python language basics. This will be the variables theory, where we'll learn about what variables are and how to use them specifically from a Python perspective. So what are variables from a general programming perspective, so not necessarily Python specific? Well, variables simply act as placeholders for data in our code. That means we assign values to them, and those values can change, or we can retrieve those values as needs be. Typically, there are three components that make up a variable. There's the name of the variable, the type of the variable, and the value assigned to that variable. Now, the name is nothing specific. Generally speaking, we want it to tell us what that variable is going to represent. For example, if you're storing someone's age in a variable, maybe you'll want to call it age or something like that. The type of a variable determines the kind of values or the kind of data that that variable can hold. For example, is it numerical data or text data or true or false data? Those will all be different kinds of variables. And the value is just whatever we've assigned to the variable. This can usually change as needs be. Most programming languages have a way to declare a special constant or a final variable that cannot change once it has a value, but that's not the case in Python. There's nothing like that built into the native library. So at the end of the day, variables really are nothing too fancy. It's just a way to store values and data throughout a program's execution. Now, there are two steps to creating variables. These can be separated into declaring and initializing those variables. So the declaring step, or declaration, is simply creating a variable and assigning a name and usually a type. In Python, we actually don't explicitly assign a type. We just provide the name and the value, and the compiler interprets the type once it has a value. The next step is initializing. This is where we take a variable we've declared previously, and then we assign it a value. This we do by guessing the name of the variable, equals, and then whatever value we want to assign. Now, generally speaking, in Python, we do this in one step. We don't often declare a variable, then initialize it later on. But there are always exceptions. There will be times when that is appropriate. So let's talk about the variable types, what that means, because there are some differences in Python compared to other languages. So we know that types dictate the kind of data that a variable can represent. And we know that we don't explicitly assign a type to Python variables. So that means when we call upon the variable, we create it, we don't say like this is, for example, an integer variable, this is its name equals something. We simply just get the name equals some integer value, and then the compiler knows that we're talking about integers. So that's one way that this is very different from other languages. The second big way that variable types are different is that Python variable types can change. So that means that, let's say I start out with some variable that's storing numerical data. Maybe I want that same variable to store text data later on. Most other languages won't let you do that. They're called statically typed languages. Python, however, being really flexible, will allow you to do that. You can totally change the type of variable as the program goes on. This is great in terms of adding that extra flexibility, but that also forces us to perform these checks to make sure we know what kind of data we're dealing with, because if we try to feed, let's say, text data into a numerical operation, it's probably not going to work. Now in Python, we have the four basic types. Two represent numbers, and the other two represent text and true or false values. So we have integers and floats for those numbers. Ints, or integers, are whole digit numbers, positive, negative, or 0. As long as there's no decimal, it's an integer. Whereas floats represent all of the decimal numbers. Lots of other languages also have doubles as well as floats, but Python just has floats built into its native library. So whole numbers are ints, decimal numbers are floats. There are also strings, which are text data. So this could be messages or names, notifications, anything that will store some kind of text data. And we put these between the double or the single quotes. So we can use either in Python. There's no notion of characters versus strings that you might see in some other languages. As long as, again, it's between those quotes, we can't mix up the quotes, so you couldn't have like one single, one double, or vice versa. Just stick with one of the two. And then finally, booleans are perhaps the simplest. These are simply true or false values. So if it's not true, then it's false, and if it's not false, then it's true. Also note the capital T and capital F, those weren't mistakes. That is actually the correct notation. It's capital T and capital F for true and false. Now here's just a couple of really quick examples. I've created 4 variables here. This is some actual Python notation that we would see. Nothing too exciting for the actual values stored. We just have a string variable that's storing some string. Note the double quotes there. So that would be some kind of text. We could have an integer variable. That whole number again is an integer. We have that float variable underneath. That's 9.9. It's a decimal number, therefore it's a float. And then we have the Boolean variable, which is just equal to true. So if it's not true, then it's false. It has to take on one of those two. Also note how I've named these variables. So I have the 2 words separated with an underscore. That's typical Python notation. You don't have to follow this naming convention, although I personally have found this is much more widely used in Python versus the camel case that you might see in other languages. It's really up to you how you want to name your variables. Just at the end of the day, consider that other people might be reading your code, as well as you later on down the road. So you do want to make sure that your variables are, the names actually make sense. You can tell what kind of values those variables represent. Okay, so that has been a really quick intro to variables. Again, at the end of the day, they're just a way to store data or values in your code, which you can retrieve or change as needs be. So that's it for this section. In the next one, we're going to turn to some actual code examples where we'll be able to provide some perhaps more practical examples than just string or int or float variables, etc. So stay tuned for that. You might want to get a Jupyter notebook started up, as that's going to be our main platform which we'll be using to showcase these examples. So thanks for watching. We'll see you guys in the next one. What's up everyone, and welcome to the code portion of our Intro to Variables tutorial. Here we're going to put into practice what we learned previously and go over some practical examples. So let's head on over to a Jupyter notebook now. I've got a blank one started up here. It's just called Variables. I do trust that you know how to use Jupyter notebooks. If not, then I've done a tutorial on how to install and use Jupyter notebooks. It's one of the best ways for writing these Python tutorials. So please check that out if you don't know how to use them. Otherwise, you basically just write the code and run it, and you do kind of one cell at a time. Alright, so I figure we might as well just create some variables, get them out there. Think about some examples of where we might use variables in the programs we write, show you how to change values and how to actually retrieve the type of variable, because that's a very important part of Python. So let's say we have this example here. I want to buy some stock. Okay, so I want maybe 100 shares of whichever stock we want. Maybe Apple's a pretty classic example. Okay, I want 100 shares of Apple. The price is I don't know, whatever price we want. Maybe it's like 171.06, and the market is currently open, so I can actually place trades. So I'm just gonna put that on a new line. There we go. By the way, if you aren't already aware, anything that is preceded by this pound or hashtag is considered a comment, so it's basically ignored by the compiler. It's really just there for us as the coders to actually read. Okay, cool stuff. So how am I going to go about doing this? The first thing I want to do is see which parts of the sentence represent the variables themselves and which parts represent the data. Well, here I want a certain number of shares of this stock, so I'm going to probably have a number of shares variable and the stock name. I have a specific price and the fact that the market is open. So that's 4 pieces of information, and of course the values are 100 shares, this is the stock name Apple, this is my price, and it's true that the market is open. So take a second here to think about how you might set up a string, an int, a float, and a Boolean variable with this information. Okay, so here's the solution that I came up with. I might want to start with a stock name, so I'm just going to create a variable called stock name like this. And I'm going to assign it the string value of Apple. So this is a string variable. As you can see, it's between the quotes. It's capitalized or lowercase, it doesn't really matter. But the variable stock underscore name, it's a good name for it. Okay, so what about an integer? Well, I want 100 shares, so maybe I could create something like number of shares is equal to 100, or I could have volume or something like that. So this is an integer. Again, not explicitly assigning a string or an integer type, it's just interpreted through the values we're passing in. What about the float variable? Well, for that I have a price, so I could do stock price. Or, yeah, let's do that actually. We'll do stock price is equal to 171.06. So because that's a decimal number, it's a float. And then the market is open, so is market open is going to be equal to true. Okay, market's open so we can place trades. Okay, so note for each of these, we've declared and initialized them all in one go. So, for example, we've declared it by calling upon the name, initialized by giving a value. If we were to separate this into two parts, this is kind of what it would look like. So you can see that this is almost a little redundant in Python, at least right now, because we're not using this variable later on. We're just kind of using it at the same time we're assigning it the value. So that's what it would look like in Python if we were to declare and initialize separately. So we'll just get rid of that. And we're not really doing anything with these variables, we're just creating them. So let's just go ahead and print those values out just so that we can see them. Stock name, and we'll do the same for the others. Okay, so then under here we have number of shares. This print function, by the way, will just kind of print whatever out to the console, whatever we pass in here. So it's a good way of checking to see what kind of values our variables hold. So then if we were to run the cell, we get the actual values that we passed in there. Now let's say at a certain point in time, as is usually the case, the stock fluctuates throughout the day. So maybe at the end of the day, my stock price is actually 173.69 or something like that. Okay. What if we go ahead and print out the new stock price? So let's run that cell. Well, now we get the new stock price stored there, 173.69. Now the difference is that at this point in time, when we're executing this code, this is the price of the stock, because that's the only value it holds. But after we've run this stuff, we're then changing it. So the value at this point in time then is 173.69. So even if we were to rerun this particular cell, okay, we still get the old value, but as soon as we run the new cell, we get the new value. Now, the last thing I really want to cover in this tutorial is how to determine the types of our variables, because although we know by looking at it that string, integer, float, and boolean, just based on the value, at some point in time we might want to let the compiler interpret things because we want to check to see that we're dealing with the correct data. Before I get into that, I should mention there is actually one other kind of value a variable can have, and that is the none value. And oh, actually that should be capital N. Yeah, there we go. So that's how you know it's a native value there. So we can assign a variable the value of none. So for whatever reason, we actually don't have a price for our stock. And then we were to print that. Okay, let's run that cell. Then we get the value of none printed out. Now, be careful when assigning the value of none, because it first of all means that we're giving this no value. It's not like it's 0 or an empty string like this, okay? We're actually assigning it the value of none. So it's the same as null or nil in some other languages, which means that if we try to perform operations on a none variable, that can give us unexpected results and a lot of problems. So just wanted to make you aware that that is out there. Now, the last thing that I said I wanted to cover is by determining the type of a variable. So for that, you can actually just use the type function. So this just determines what type of variable we're passing in. We've just changed stock price to none, so I'm not going to get that. But maybe we want to check to see what number of shares versus stock price is. They're both numerical variables, but we might not necessarily know what kind it holds at a certain point in time. So maybe we want to do the type of number of shares as well as we called it stock price. We'll have to actually, this will return the type, but we'll probably want to print that result out. So we can just wrap this in a print function. This will print things out. Okay, so let's give that a run. So you can see we get a class int and the class none type. Oh, that's actually stock price. That's because we assigned it the value of none. So let's just quickly assign it. Now we'll say stock price is going to be equal to, let's set it back to this guy. Okay, and then we'll go ahead and rerun that cell. Okay, so we get int here and float here. Similarly, you'd get a string for the stock name and a boolean for is the market open. We can actually change between types by assigning the type that we want to use. For example, let's say I want to change my stock price to string data. I want to change it to text data. What I can do is say string of stock price, okay? And I can say maybe price string, price underscore string is equal to the string of stock price. Then if I want to print out my price string type, so type of price underscore string, like this, then as you can see, I get the class string assigned to that. So this is basically taking whatever value it finds here, converting it to a string, storing it in this variable. Then I'm just getting the type of that variable and printing it out. So that's kind of the order in which things are happening. Be aware that there are some conversions we cannot perform. For example, it doesn't make sense to try to convert this to an integer, okay? Or to convert this to a Boolean variable. So some things just make sense and some things don't. What I would encourage you to do is try some of this stuff out for yourself. Maybe try to come up with a new string, new int, new float, and new Boolean value. Okay, try to print out the type of each of those. Try to work by changing the type. Maybe try an example where you reassign a completely different type, so maybe some text data to what was previously a numerical variable. And once you're ready to move on, we'll take a look at some more exciting stuff we can do with various operations. So, thanks for watching. We'll see you guys in the next one. What's up everyone, and welcome to our tutorial on variable operators in Python. Here we're going to learn some of the operators and the corresponding operations that we can perform on those variables which we covered previously. Now we'll be breaking our operators into 5 main categories. We'll start with arithmetic operators, then look at assignment operators, then equality operators, ternary operator, there's only the one, and then logical operators last. Now there are actually a few other categories which we won't be covering in these tutorials just because I find myself very rarely using them, and certainly they'll have nothing to do with the topics that we'll be covering later on in these tutorials. So for starters, the arithmetic operators are categorized into just the regular binary operators. So these are very much like your basic mathematical operations. You've got addition, subtraction, multiplication, and division. Those work exactly how you'd think, with typically a number on the left and right hand side, and then it just returns the results. Now there's 2 more operators here. You can see the double forward slash and the percent sign. Well, the double forward slash is floor division. Basically, it will perform division and discard the remainder, just returning the result. So for example, if I did 5 floor divide 2, then I would just get 2 because it has a remainder of 1 which it just discards. On the other hand, the modulus operator, that's the percent sign, that will perform the division and return just the remainder. So with that same example, 5 modulus 2, then I would just get 1 back because it discards the results and just returns the remainder. Next up, we have our assignment operators. These are broken into just the single assignment and then kind of a combined assignment and arithmetic operator set. So the single assignment we've actually seen. We basically place a variable on the left and a value on the right, and it's just assigning a value to that variable. With the arithmetic and assignment operators combined, this will perform some kind of arithmetic operation on a variable, and then it will store the results back in that variable and can be performed with any of the basic arithmetic operators. For example, let's take the plus equals operator. If I had a variable whose value was 5 and I did that variable name plus equal maybe another 5, then the results would be 10, which we would store back in that same variable. Now that might be hard to visualize, so we'll definitely run through some examples of these operators, but they're really not so difficult to grasp once you see them in action. Next up are the equality operators. Now these will just test some kind of equality between 2 values, whether they're equal, not equal, greater than or equal to, less than or equal to, and they'll return either true or false based on the results of those tests. So just be aware that they will always return a Boolean true or false value, and typically we use them to test either numbers, strings, or Boolean variables. If we're testing objects and classes, if you know anything about that, then we'll use a different operator for that, but we can cover that in that classes and objects topic. For now, just performs a comparison and returns true or false. Next up is the ternary operators. Now I said operators, that should actually just be operator, there's just the one. This will test a condition and it will return one of two results based on whether that condition is true or false. Basically, if the condition tested us just after the if, that's our first underscore, returns true, then we store the value of result, else we store the other value, that's that last underscore there. Now that one again is pretty confusing until you actually see it in action, but we're actually not going to cover that in this section. We're going to be covering that when we talk about control flow, because it really ties in well with that whole theme of if and else statements. Last up, we have our logical operators. There's the basic not operator that's just used to negate a Boolean value. So if we negate a true, it becomes false. If we can negate a false, it becomes true. That's just the basic not operator. Additionally, we have the and or operators that allow us to test additional cases. So let's say we're testing equality between two variables, so like is something greater than another one, and then we wanted to stick some additional cases in there. Well, that's where the and the or operators come in handy. The and needs all of the cases we're testing to be true, but the or operator needs only one of the cases that we're testing to be true to actually return true overall. Again, we'll come to some examples with those, as we will with just about all of these operator classes. Of course, particularly with these operators, it definitely means a lot if we can actually see them in action versus just kind of hearing about how they're supposed to work. So that's what we're going to do next up. We're done with the slides, so we'll be right back with the demo portion. So, as always, thanks for watching, and we'll see you there. What's up everyone, and welcome to the code portion of our variable operators tutorial. This I think we're going to break into two parts. Here we'll cover one set of the operators, and in the other section we'll cover the other set. So here we're going to focus more on the arithmetic and assignment, and in the next part we can focus on equality and the logical operators. So let's head on over to our Jupyter notebook. This is the same one that we worked on previously. As you remember, it's called variables. We started out with this stock buying example and then worked on just modifying and printing out the types and the values. So what I think we're going to do is actually just run this first cell because I just want these values here. I don't want the modified values. So right now we get stock name equal to Apple, number of shares 100, stock price 171.06, and is market open equal to true. Okay, so let's focus on just the arithmetic and assignment operators here. These two actually have a lot of crossover, especially the assignment ones, because there's some arithmetic assignment combo operators. But we'll first focus on arithmetic. So here we get our basic operations such as addition, subtraction, multiplication, and division. Likely we've all seen those in school at some point. But we also have the floor division and the modulus operator. So remember, this performs division and discards the remainder. This performs division and just returns the remainder. So it discards the actual results of the division itself. Let's start with some basic numerical examples. I think we'll work just with the number of shares because ints are slightly easier than floats. So let's say I have a certain number of shares. This is equal to 100 right now, and I want to increase my total purchase to 150 shares. Maybe Apple fell to a really, really good price. I know it's going to go up, so I want to up the number of shares I'm going to buy. So I could just set this to 150, and that would be the end of it. But what if I don't necessarily know what my current value of number of shares is, and I just want to add 50 more onto it, regardless of how many I currently have? In that case, I can simply add 50 to it, like so, and then it would return the result. So if I want, I could print this out. Okay, so print number of shares plus 50, I get 150 like this. Or if I want to store this in a new variable, I can do that too. So maybe I want to do something like new number of shares is equal to the number of shares plus 50, okay? And then I want to print out my new number of shares. So this actually isn't going to modify the original number of shares. In fact, let me demonstrate that too. Okay, let's just print out the regular number of shares. So you can see we get 150, or 100 rather, for the number of shares, and then 150 for the new number of shares. So we're actually not modifying this at all, we're simply retrieving its value and adding 50 and storing that into this new variable, but we're leaving the original one alone. If I'd done something like this, number of shares is equal to number of shares plus 50, well then this no longer exists, so let's cut that out. Let's rerun this, and now I get 150 stored in my number of shares variable. Now there's actually a shortcut to doing exactly this, which we'll see in just a few minutes. I just want to cover some of the other arithmetic operators first, so let's kind of leave that example like that. Alright, by the way, I know these both just increased by 50. That's because Jupyter Notebook is keeping track of these current variable values. If we want to return them to the original, we have to run this, and then we run the cell. There we go, 100 and 150. Okay, so the next arithmetic operators I want to cover are going to be our floor division and the modulus operators. I figure we can leave out the subtraction, multiplication, and division because they work really very similar to this, and I trust that at some point in your lives you've seen those operators in action. So the ones I'm interested in, again, floor division and modulus. So I think we'll stick with the current number of shares, 100, for this demonstration. So let's say I want to divide the total number of shares that I'm buying into 3 different batches. We know it's not going to go evenly because 100 divided by 3 will give a remainder or a repeating decimal number. So this is a good way to demonstrate both the floor division and the modulus operators, as they'll give us different results. But let's just say I want to divide it into 3 batches so that I'm not buying all at once. What I could do, I'm not going to bother storing these in new variables, is see what number of shares floor division 3 would be. Okay. Actually, you know what? Let's demonstrate all 3. We'll just do the basic division. Then we'll do the floor division and then the modulus, just so that we can see all 3 in action. So let's run that. So we get 33.333, etc. if we just do the basic division. Also note that this is now a float. So it started out as an integer, but has been converted to a float. Or rather, at least the result is a float. We're not storing. If we stored it back into number of shares, that would then be a float, just because we're dealing with decimal numbers now, and the type is fluid in Python. A lot of languages won't actually let you do this. They require only float on float or int on int operations, so you'd have to do conversion, but Python's super flexible and super user-friendly, so we don't have to do that. Alright, so we get the decimal number for the basic division, makes sense. For our floor division, we're performing this and returning the remainder. So we'd get 3 groups of 33 with a remainder of 1. So it's basically just discarding that remainder, whereas the modulus operator is discarding this and just returning us the remainder. So in this case, just 1. Alright, so that is our basic arithmetic operators. The next is going to be the assignment operators. We've already seen one of them in action, right here, and pretty much in all of these cells. This is just taking some variable and assigning it a new value, on the right-hand side there. I should also note we can assign variable values as well, not just literals. So if I had some other variable that contained a price, something like that, I could do that. Obviously this variable doesn't exist yet, but if it did, then I could do that. I don't have to just pass in literal values. Alright, aside from that basic assignment, we can do the assignment arithmetic combos, which again are our plus equals, minus equals, divide equals, multiply equals, floor division equals, and modulus equals. These all work in pretty much the same way to each other, just performing the different operation each time. So the way those work is they perform an operation on a variable, and then they store the results back into that variable. So you remember I said there's actually a shortcut for doing something like this if we had the number of shares equal to the number of shares plus 50. So we're changing its original value. We can actually use the plus equals operator for that. So let's go ahead and run the number of shares equal to 50 or equal to 100, just so that we can reset this. Okay, so number of shares is 100 right now. What we want to do is add 50 to it and store the results back into number of shares. Well, we could do something like this, equals the number of shares plus 50. Nothing inherently wrong with that. But the shorter form would be to do plus equals 50. and that's doing exactly the same thing. It's taking its current value, it's adding 50 to it, and then it's storing it back into number of shares. So if I print number of shares now, actually I think I have that copied, then I get 150, which is really nice. That just saves a bit of time, especially if your variable names are really long. The minus equals, multiply equals, divide equals, floor division equals, and modulus equals all work in exactly the same way to this operator, so I think no need to demonstrate those. Now, I think at this point we've covered all the operators. There is one final thing I want to talk about, and that is using these operators on strings. So the addition operators at least can be used on strings, not so much the others, but we can glue two strings together in an operation called appending the strings by using this or our basic just addition operator. So let's say my string right now is stock name equal to Apple, and I want to change this to Apple Inc. like this. Once again, I could just reassign it to Apple Inc., but maybe I just want to add Inc. onto the end of it, so I can do stock name is equal to my stock name plus, and then I can just add that string onto the end of it, Inc., like so. Then if I want to print out my stock name, I should see the value there. Okay, so now it comes out to Apple Inc., and that's done just through the same addition operator. You could use append operators as well. There are some functions that will do this for you, but this works just as well. Now, I should say that we have to add in this white space explicitly. If I just do something like this, it's going to glue them. Whoops. Okay, let's just actually reset stock name there. So stock name is equal to Apple. Okay, so if I just do this, it's going to glue them right together. So I have to add the necessary space. Okay, so let's go ahead and run that. Similarly, if I did something like this, okay, and then said stock name plus equals space Inc., I'm going to achieve exactly the same results there. I get Apple Inc. That's because it's taking its current stock name, it's appending this onto the end, and then again storing into the original variable. Okay, so that's it. I would, as always, encourage you to play around with this a bit. For this kind of more hands-on, actually doing stuff with the variables portion, I really encourage you to get your hands dirty, try some of these things out for yourselves, and once you're ready to move on, we'll cover the other two groups of operators. Alright, so as always, thanks for watching, and we'll see you in the next one. What's up everyone, and welcome to the second part of our code variable operators tutorial. Here we're going to cover the next two groups. Those will be our equality and logical operators, just because those two go really well together and the previous two went really well together as well. So let's head on back to our notebook, and we're going to cover equality, and also the logical operators. So we're actually going to skip the ternary operator for now. We will revisit that in a later tutorial when it makes a bit more sense to be covering that. So that will be in the control flow portion. Okay, so our equality operators are our basic equals, not equals to, greater, greater than equal to, less than, and less than or equal to. So these are literally just comparing two values and returning either true or false based on whether those results should be true or false. So for example, if we did something like 5 equal to 2, obviously that's going to be false. Those two values aren't equal. If we did 5 not equal to 2, that's true. 5 greater than 2 equal to true, and so on and so forth. Just to really quickly demonstrate, we could actually just print out those values. So let's say we did 5 greater than 2. We run this. Obviously we get true because that is true. We could also store the results of this operation in a variable. So let's do something like is true is equal to this. And then if we wanted to print out is true like so, that also works as well. We might also want to take note of the type of is true. So print type is true. And as you can see, we get a Boolean class variable. So the exact same logic works for the other operators. So less than, obviously this would be false. This will also be false. True, oh no, sorry, that's false. This is going to be true, and so on and so forth. Okay? We can also compare strings. So let's say, for example, I have two strings here. I have A, so let's say string _1 is equal to A, string underscore 2 is equal to b. And I want to compare the two. I could do print string 1 greater than string 2. Okay, and I'm going to get false. So weirdly enough, I can also compare these strings. Essentially, the further along the alphabet we are, the greater the string value is. It's considered to be greater. So that's why we get this false here, because string 1 is closer to the beginning of the alphabet than string 2 is. So it's not considered greater. It's actually considered less. Now, that is the basics of our equality operators. The logical operators next are going to be our not operator, our and our or operators. So the not operator is often just an exclamation mark in most languages. In fact, I think Python is the only one I've worked with personally where it's a not instead of an exclamation mark. And it makes it kind of confusing because this is not equal to, but this is not. I don't know. That's just Python syntax for you. So, but not will basically negate a Boolean value. If it's true, it turns it to false, and if it's false, it turns it to true. So, is true here is equal to true right now. If we just print not is true, and we run it, then we get false. And vice versa. If it was false, then we would get true. The more interesting ones are our and or operators that allow us to test multiple cases. So typically, we put a case on the left and a case on the right to test for both the and the or operators. And if both of these are true, and returns true. If either one of those are true, or returns true. If either one of those fails, then it returns false. So let's take a look at a more practical example than just like string 1, string 2, and this is true garbage variable. So let's say we're trying to determine whether we want to buy some shares in Apple or not. So maybe we only want to buy once the price is lower than this. So we can do something like is price low enough. I know that's really wordy, but that's fine. Is going to be equal to our stock price less than or equal to 170. Let's say at 170 we'll buy the stock. So say is price low enough is equal to our current stock price is going to be less than or equal to 170. Let's say we can also only buy if the market is open. So that makes sense. So is market open is equal to, let's start off with false. Okay, so let's go ahead and print this. Well, we want to print whether or not we can actually make the purchase. So in both of those cases, we want this to be true and this to be true. So we'll do is price low enough equal to true, and is market open also equal to true. Let's go ahead and run that cell, and then we get false. So the market is not open, that makes sense, that's false. Also, the stock price is not less than or equal to 170. I think at this point it is, I don't think we ran those cells, so I think at this point it's actually 171.06, okay? If we change this to an or, and maybe change that to true, because both of those cases were false, and then go ahead and run this, we actually get true this time, okay? That's because only one of these needs to be true in order to return true with an or, whereas both of them need to be true if we are doing the and operator. So this makes a bit more sense than the or operator because obviously we need both of them to be true. So in this case, because we're testing to see if something is true, the better syntax is actually just to do this. We can eliminate the equals true altogether because this is storing either a true or false value, and so is this. And so by calling upon the variable, you're simply retrieving the value at that point in time anyway. So there's no need to test to see if it's equal to true or equal to false. You could just do this for true and not for false. Okay? So I think that just about covers everything we want to go over. We just wanted to take a look at our equality and logical operators, and we've done just that. Again, the equality operators all work the same way, just returning true or false based on a comparison. We can also compare strings. Again, the ones closer to the beginning of the alphabet are lower or lesser than the ones towards the end of the alphabet. Also, we tested the logical operators. Not just turns a Boolean and flips it around. If it's true, it goes false. False, it goes true. And also the other logical operators. The and allows us to test multiple cases, returns true if they're both true. And the or operator allows us to test multiple cases and returns true if either one of those is true. I should end this by saying we can add a long chain of different tests, so we can test 100 different things if we want, all in one go, although I wouldn't recommend doing that. Just note that it is possible. Okay, so that's it for our variables topic. I think we're done here. Now we can move on to the next topic. So stay tuned for that. As always, thanks for watching, and we'll see you in the next one. What's up, guys, and welcome to a new topic in our Python language basics. This will be all about collections. We'll start off with lists, then move to tuples, and end up with dictionaries. So here we'll just learn how to set up and use lists of values in Python. For starters, what are lists from a programming standpoint? Well, lists here are really not so different from lists in the real world. It's just a way to store multiple values in a single location. In our case, that one location is just simply in a single variable. So basically, all of the variables we've seen so far can only ever hold one value at a time. Even a string that is maybe 20 or 30 characters long is still considered one variable value. In our case, we'll be able to store multiple values in a single location using these lists. In other languages, these are often referred to as arrays, although many other languages also call them lists and have other variations. Lists in Python, as well as most other languages, also come with a variety of built-in functions that help to manipulate them or retrieve various components or properties of the lists. So this could be just accessing or modifying individual values, maybe inserting values at specific locations, or just retrieving properties such as the number of items, or maybe the maximum or minimum of the list. Now, lists in Python can actually have multiple types of variables. This is something that's unique to just a handful of programming languages. Most languages require you to define just a single type of list. So, for example, a list of strings or a list of integers. In Python, we don't have to specify that. We could have a list that contains some integers, some strings, some floats, and so on and so forth. Although, as much as possible, it makes the most sense to keep one type of variable in a list. This just makes things a little easier when we're calling upon other various operations within lists. So the first thing we might want to do after setting up a list is fetch individual elements. So we can actually fetch multiple elements or different parts of a list through these built-in functions. But if we want to access just one element, then we do so based on index. Python, much like almost every other programming language out there, I think there are a few that aren't, most other programming languages as well as this are zero-based indexing. So that means the very first index is a 0 rather than a 1, and the very last index is the length of, in this case, a list, minus 1. So let's consider a list with 5 elements in it. The first element is at index 0, the second index 1, third index 2, fourth index 3, and the final element is at index 4. Okay, so that's very important to note when we're fetching elements. If we want to access the entire list, then we can just call on it by its list name. And then that way we can treat it much like most other variables. What about setting list elements? So this means either modifying the whole list or parts of the list. Well, much like with other variables, we can change the entire list by reassigning it to a new list. Interestingly enough, just like with most of the other variables, we can actually assign a variable that previously contained a list to contain only some other single value. For example, if I stored a list of numbers at a variable, I could then later on in my code change that same variable to contain only one number, or a string, or something like that. However, if we want to modify individual elements of a list without using the built-in functions, we simply access an index in that list and set it to a new value. This looks very, very similar to reassigning just a single value to a single variable, except that we access an index in the list. Now that does mean that we have to make sure that index exists, otherwise we're essentially trying to access something that doesn't exist in a list. So there's definitely some restrictions and some checks that we need to perform. Now I always find a visual aid helps a little bit, so let's take a look at a quick example here. So let's consider the scenario where I have my stock apple that I'm still interested in, and I'm getting the previous 5 days' prices. Now, so I have the results stored in this list called past 5 prices. I've got numbers 171.06 ranging through 176.98 in no specific order. This is just kind of simulating some previous prices I might have seen. So if I want to fetch an individual element, as you can see, I'm accessing the list name In the square brackets beside it, I'm accessing the index that I want. In this case, index 0 will give me the very first element, and I'm just retrieving that and storing it in a variable called first price. Now, because this is a list of floats, these are all decimal numbers, first price will take on whatever value it's retrieving and the type of value. So in this case, first price is equal to 171.06 and is of the type float. In the next line, I'm taking that same list, first 5 prices, accessing the index, or the elements rather, at index 2. So that's the middle one, 175.65. And I'm changing it to a new value. Maybe I made a typo or something, and I want to change that to 174.65. So at that point, the list would read 171.06, 172.03, 174.65, then 179.50, 176.98. Okay, so that is actually modifying the original list, and so it contains that element at that index specified. Finally, I just want to finish up by talking about some common list operations and how to access them. Now, in the demos, we're not going to go over every single operation because there are quite a few to choose from, but I'll show you how to access a few of the more commonly used ones, such as appending, popping, getting the count, and inserting elements. And that's all done through the list name, dot, and then the operation we want to retrieve. It's actually easy to see a list of operations that we might want by turning to any kind of list documentation. Unfortunately, the Python or the Jupyter notebooks don't actually give you any kind of autocomplete feature, so you can't see all of the operations available, but we'll take a look at some of the more common ones. So appending is just adding elements to the end. Popping is removing an element from the end, or I think we can specify a certain index too. Count is just retrieving the number of elements in a list, and inserting is placing a new element at an index in the list. One last thing I want to end up on is that lists in Python are mutable. So that means that every single list can be modified, not just the individual elements, but the length of it. We can add items to it, and we can remove items from it as well. It's not necessarily the case in all languages. Some have specific lists that are non-mutable, which means you can't change the length of them. And some have mutable lists, which will allow you to change the length. So it's all one and the same in Python, being the flexible language that it is. So that's it for the theory. Let's put into play some of what we just covered in the demo. So that's coming right up. As always, thanks for watching. Hopefully you'll stick around for that, and we'll see you there. What's up everyone, and welcome to the demo portion of our Intro to Lists tutorial. Here we're going to set up a list, take a look at how to get and set elements, and then explore some common operations we could perform on lists. So let's head on over to a new Jupyter notebook. This one I've just called Collections. It's blank. I figure I'll probably start a new notebook for each of the main topics that we'll be covering. That way we can get some separation between the code and we're not kind of reusing old code. Okay, so for lists, I think it's best to stick with one example, kind of roll with that throughout. I'm going to come up with the example of having a list of stocks I'm interested in. So I'm going to create a stock watch list. So we can put whichever stocks we want in here. I'm just going to call mine like stocks list or something. And then we need to set up the list. Now there's a couple of ways we can do this. We can create a list object like this, or we can just add the square brackets like this, and it does exactly the same thing. So either way, they're both going to be lists. I personally prefer doing things this way, because then we can enter values in right away as needed. So we'll just do a list of strings, but again, lists could take on whichever type. It could be a list of integers, floats, booleans, a list of different objects if we create them ourselves. In this case, we'll just go with strings. So I'll just enter a few of the stocks maybe that I'm personally interested in. So let's do Apple, maybe we'll do Microsoft, and maybe we'll just do Amazon. So 3 pretty big tech stocks here. Feel free to use whichever examples you would like. So if we want to print out our stocks list, it should look pretty much exactly the same to how we set it up. So just Apple, Microsoft, Amazon like this. Note the single quotes denoting strings, and also the square brackets denoting that this is a list. We can reassign the entire list to something else if we want. So we could do like stocks list is equal to an empty list like so, and it will reassign the entire list just like any other variable. The power of having this whole list though is that we get all of these elements, so we get multiple different values rather than just a single value. Okay, I don't really want it to be an empty list. I do actually want it to contain some items, so we'll leave it at that. Okay, so we know how to get the whole list. What about just one single element? Well, we do that based on its index. Index 0 is the very first one, and the very last one is the index equal to the length of the list minus 1. So if this is the index, or this list has 3 elements, then this is the index 2. So it's the length minus 1, that's going to be the very last index. So 0, 1, and 2. Okay, so to access an element, we simply put the name of the list, in this case stocks list, open up the square brackets, and then put the index we want in the square brackets. So if I want the first element, it'll be index 0, second element, and third element. So let's say I want to call this Amazon stock name is equal to stocks list of this, and then I want to print that out. It really should just return me the stocks list at the index 2, which will just be the string Amazon, and that's exactly what happens. So setting items, individual items that is done in exactly the same way. We just get the index we want. So in this case, stocks list of maybe we want to change Microsoft out for Google or something. We get the index 1, that's where Microsoft is located. And we just replace whatever's there with a new value. So in this case, we'll just do Google, something like that. And then if we were to print out stocks list, this will change up the list, just replacing that single element with the new value we passed in. Once again, lists in Python can contain multiple types, so this could contain not necessarily just a string, but pretty much whatever we want. One final note before moving on to the operations is that there is no array bounds checking automatically built in. So what that means is that our array has a finite length. That length can change. We can add elements or remove elements. We can empty the list completely depending on our needs. But because of that, we can never be 100% sure exactly how long our list is. If we try to access something in a list that doesn't exist, then we get an error thrown. For example, let's say I try to access stocks list at index 5. So let's just print that out. Okay, and let's run this. This throws this big ugly error saying that list index is out of range, and unfortunately this is an error that would crash your program if not handled properly. It doesn't just fail silently like in JavaScript where it won't crash the program necessarily, it just won't do anything. This will cause your program to stop running if not handled properly. Similarly, if I tried to reassign this to a value, so if I tried to say stocks list of 5 is equal to, I don't know, some string, that's not allowed either, because this index does not exist in this list. We can only access the indices 0, 1, or 2. Okay? So for that, it's always a good idea to try to check how long your list is before you try to change or retrieve anything from it. We can do so with a simple length operator. So for example, if I want the length of my stocks list, I get 3. And that way I can just check every time I want to access something, see if the index is greater than the length minus 1. Or I guess greater than or equal to. If it is, then we're safe. If the length of the list is less than or equal to the index we're trying to get, then that index doesn't exist. Okay, so it's always something you want to check. Okay, so what other operations might we want to check out? I think it's kind of impractical to go over all of them, so I'll just go over some basic ones. We know how to get the count or the length. Let's take a look at how to add elements, how to insert elements, how to delete elements, and also how to remove elements. There are other operations that we can explore, which I would actually really encourage you to do. Check out the Python documentation or something like that. But it's just a little impractical for me to cover all of these. Okay, so we know how to get the length. Let's try to add something to this list. So we get our stocks list, and we want to maybe stick something onto the end of it. And so that's done through an append operation like this. And we just want to choose which item we want to add. Maybe we want Amazon back, or I think we replaced Microsoft actually. Maybe we want Microsoft back on the list. So let's just print our stocks list after this. Check it out, we get Microsoft stuck onto the end. If we want to add a list rather than a single element, then instead of append, we do extend. And then we have to wrap this in a list like so. You can have as many elements as you want in that list you're extending. Okay. Alright, so that's the append operation. What about the insert operation? And actually, I guess we'll start a new cell for each of these. Okay, so the insert operation is going to add an item at a specific index. Now, the order is actually pretty important. We do, let's say we want to insert an item at index 1. So we're basically inserting this item right here. So index 0, and then at the end of index 1, that's where we're inserting it. Or I guess actually this is index 0 and index 1, so it would insert it right before Google. We want to call upon the insert function, and then we're going to put in the index, in this case 1, and then the stock that we want to add to this list. So maybe this is going to be, I don't know, pretty interested in AMD as well. So let's just take a look at what this looks like now. Oh, and it's running the append operation again, but you get the picture. So now it looks like we're kind of all messed up here from the different cells running. So let's run these from top to bottom again. Okay. Alright, so this is what it would look like now. We get first, after appending Microsoft, it looks like this. Once we insert AMD at index 1, it will look like this. Okay, so what about deleting or removing items? Well, if we want to call upon the delete function, we have to pass in the index which we want to delete. The remove function will remove a specific item from the list. So we add the item we want to remove versus the index we want to remove the item from. So our stocks list looks like this right now. Let's say we want to get Apple out of here. Okay, so we basically want to delete stocks list at index 0. In that case, we'll just call upon a delete function like this. And then we'll just print out stocks list to see how it looks after this. I guess I should run these on separate cells really to avoid any issues like that. So now our list looks like this. You can see that Apple is out of there. On the other hand, if we want to call upon the remove function, we simply do our stocks list.remove, and then we enter the item we want to remove. So let's say we want to remove Amazon from this list now. And then we want to see what it looks like. We can run the cell, and as you can see, it's removed Amazon. So that's the difference between the two. This takes an index, this takes an object to remove. Similarly, there is a function called pop, which takes an index, so let's say index 2, that would just simply pop this guy off the end of it, which is kind of the same as deleting this index. Essentially, they function the same, it just kind of comes down to personal preference. Otherwise, that is just about all of the main functions we might come across. I will actually say really quickly, there is a function called count. Don't let this fool you. This won't return the length of the list. Remember, that's what we use our length operator for right up here. That returns us the length of the list. This guy returns us the number of times it sees an object. So for example, if I did Microsoft, this would return me 1, okay? You know what, might as well demonstrate it while we're here. So let's just print that out. As you can see, it returns 1 because it says there's 1 occurrence of Microsoft. So this is the count, the number of times it finds this, rather than the length of the list. Okay, so that is most of the operations. There are still a few, but I find myself not really using the others too often. I can accomplish most things I need with this. If you are working with a regular IDE and not these Jupyter notebooks, then you can very often just pull up a list of all of the operations by typing in your list name and then, whoops, stocks list, and then calling dot, and then it will come up with a list of the operations. Unfortunately, Jupyter doesn't do that. Another one of the reasons I don't particularly love working with Jupyter notebooks, but we're going to have to do Jupyter notebook work later anyway, so we might as well get used to them. Otherwise, feel free to check out the other functions in maybe Python documentation if you are feeling particularly ambitious. Play around with lists a little bit, maybe come up with another example of where we might contain a list of values. Take a look at how to perform some operations on that list, fetch and set operations, as well as some of these guys that we covered. And when you're ready to move on, let's learn about tuples. So, thanks very much for watching. We'll see you guys in the next one. What's up everyone, and welcome to the second tutorial in our collections topic. This will be on an intro to tuples, or sometimes they're referred to as tuples. So we're going to learn how to set up and use tuples in Python following a very similar format to that with lists. So for starters, what are tuples? Well, on the surface, they function and look very, very similar to lists. Tuples provide another way to store multiple values in a single variable. Typically, these values are all related in some way. We'll be seeing in the examples that we can hold different kinds of data that all help to represent a single item. However, unlike lists, they're not generally used to hold many different values. So whereas we might have like a list of prices or a list of stocks we're interested in, a tuple is more about holding multiple related values that all relate to a single item. Tuples also provide a way to hold multiple types of values just like lists. For example, we could have strings, ints, floats, and booleans all within the same tuple. So generally speaking, we hold just a few items rather than, 10 or 20 or 30 items, as is the case with a list. So how are tuples different from lists then? The usage in general is different. We talked about the context in which we use tuples versus lists. Again, list is if you want to hold multiple items that all somehow serve the same purpose, whereas a tuple is used to hold a few related values. Tuples are also read-only. That means that we can only retrieve items or retrieve properties from them. We cannot actually change individual items. There are also much fewer operations that we can perform on tuples as a result, because of course all of those modification operations kind of are out the window. Okay, so we can really think about tuples as being a much more rudimentary form of a list. So here's a really quick example, and actually we're going to look at a very, very similar example once we turn to the code. Here we have an Apple stock and it's priced at $171.06. So a tuple might look something like this. We'll call it Apple stock. In the brackets we'll have the stock name Apple and we'll have the price $171.06. Okay, so you can see that they are different kinds of values. They're kind of representing different pieces of data, but they're all somehow related to the single item, that being the Apple stock itself. If we want to retrieve a value, again, we would just get the name of the tuple and the index that we want. In this case, index 0 will return us the name of the stock. Okay, so that's it. If we know how to use lists, then we'll know how to use tuples just fine. So we're going to end this section here and turn to the code where we'll take a look at a quick example of using a tuple. Don't worry, this one will be much shorter than the list portion. So thanks for watching. We'll see you guys in that tutorial. What's up everyone, welcome to the demo portion of our Intro to Tuples tutorial. Here we're going to put into play some of the stuff we learned about tuples. Basically just a simpler version of a list, and because there's a lot less that we can do with tuples, this is going to be really short. So let's head on over to the code now. This is the same Jupyter notebook that I used for the lists. You can see it's called collections here. So it will just be working in these cells down here. We can basically ignore all of this stuff. So our goal is to focus on tuples. I think we'll follow the same format. We'll start just by creating a tuple, talk about what it's going to represent, talk about how to retrieve elements from a tuple, because of course you cannot set elements, so we'll have to skip over that. And then we'll talk about the few operations we can perform on tuples. So a good deal of this stuff won't really apply, because like I said, there's no real modification functionality there. Okay, so I want to kind of map out a stock purchase. So I want to map out the purchase of a stock. So I need the name, price, volume, and you know what, that should be sufficient. Realistically, you probably want the day, the minimum price, etc. A bunch of other things, but let's just go with these three values. So let's call our tuple something like stock purchase. Okay, and we're going to set it up very similar to our list. Instead of using the square brackets, however, we need to tell our compiler we're dealing with a tuple by entering in the regular rounder brackets. Okay, so within here we can put whichever values we want. Might as well stick with that Apple stock. Okay, and we're going to go with a price, let's say 171.06. Okay, and then we'll go with a volume. So how many shares do we want to buy? Do we want 50 or 100? Let's make a really big purchase and go with 100 shares there. Okay, so there are probably better ways of representing this stock purchase, because this isn't too indicative of what each of these items are. This really just gives us the values rather than the names, but don't worry about that. We'll talk about a better way to represent this much later on in our tutorial series. So you can see lots of similarities. I mean, we have comma separated values here. We have the values themselves as multiple of them stored within stock purchase. If we wanted to print out our stock purchase, let's see, stock purchase, we can do so. Let's take a look at what that looks like when we run it. Note that again, looks very similar to a list, but we have the round brackets instead of the square ones. Now, once again, the biggest difference is not just in the way we use the tuple, but also in the fact that none of these operations can modify the tuple in any way. So I could totally get individual values. I could get, for example, the name of the tuple. Let's say stock name is going to be equal to our stock purchase at the index of 0. If we want to print out stock name, it should give us the appropriate value there. If we run that, that's fine. We get Apple, good to go. There's also no array bounds checking, so if we try to get something that doesn't exist, once more we get that index out of bounds error. Okay, so let's stick with that. However, if I try to modify this, so if I try to say like stock purchase of, I don't know, 2, maybe I want to change that to 150 shares instead of just 100, then I'm going to get a different error this time. And it's saying that tuple doesn't support item assignment. Basically, once it's created, that's it. It's really read-only. So it's kind of like a constant in that sense. This also means that none of these operations that modify it in any way, so for example, we cannot delete it, we cannot remove items, we cannot append or insert items. None of those functions exist for tuples. There's only really a couple of functions we can perform. We could get the length of a tuple. So actually, let's actually just print that. Print the length of our stock purchase. I think I'm missing a bracket there. So we can get the length of it. I can also get the index of elements, so we've seen that we can already get a specific element itself, but let's say I wanted to get the specific index of an element, so let's say stock purchase dot index of the volume maybe. Let's see what that looks like. Then I'm going to get 2 there, and that is once again just getting the position of this particular value. Also, what I can do is get the count of the number, or the number of items that appear in this tuple. So for example, I want to see maybe how many times 171.06 appears. So I could do, for example, a print of my stock purchase dot count, and maybe I want to see how many times 171.06 appears in that tuple. In this case, I just get the 1. It works exactly the same as with our list.count function. Alright, so actually I think that's pretty much all we really needed to cover. Like I said, tuples are really simple. Generally, it's just a way to bundle together a bunch of related items. We'll see they'll come into play particularly when we get into dictionaries, which is going to be this next topic coming right up. Once more, they're read-only, which means none of the write operations will work with these. However, we can retrieve a lot of the values that we can with lists as with tuples. For the most part, if you want just a few related values that represent an item, probably go with a tuple. If you want a list of multiple values that kind of represent the same thing, so for example, a bunch of stock prices, a bunch of stock names, etc., that's probably going to be a better place for a list. Okay, so that's it for here. Let's move to our next topic, which will be on dictionaries. So thanks for watching. We'll see you guys in the next one. What's up everyone, and welcome to the third part of our collections topic. This will be all about dictionaries. We're going to learn what they are and how to use them in Python. I figure following a very similar format to the previous 2 collections topics. So for starters, what is a dictionary from a programming point of view? A dictionary is not so different from a list that we've seen previously, but each of the list elements is replaced with a key value pair. So instead of just having one value at a specific index, like with a list, we actually have a value at a specific key in the dictionary. So it might help to think of this very similarly to an actual dictionary used to define words, wherein each of the keys is the word that we're trying to define, and then each of the values is the definition. So I think that's where the name dictionary actually gets its name, and it's often called a map in other languages because you're kind of mapping values to keys rather than to indices like with a list. There's a great deal of flexibility in dictionaries as to what type we assign to the keys or values. Generally, I find myself more often than not using a numerical or like an integer key or a string key, and then the value depends entirely on the kind of data that we're trying to represent within our dictionary. Just remember that values are stored at keys in the dictionary rather than at indexes like with a list. So how are dictionaries different from lists? Well, we explained a couple of those differences, the first being the fact that, again, each of the elements is a key value pair rather than a single value. If you think about a list as being a bunch of elements placed at specific indices, you can kind of think about the key of each of those elements being its index. So you place a specific value at a specific index. With a dictionary, you're placing a specific value at a specific key. The position of that key value pair within the dictionary doesn't matter. Whether it's the first or the last element really makes no difference. And that's because our values are accessed by their key instead of by the index. So let's say I store a value at a specific key. Again, I don't really care where it is in the dictionary. As long as I'm using that key to store and retrieve it, it works just as well. This, in fact, opens up to more uses than with just lists, where you have to keep keep track of the indices of each of the elements if you want to know exactly which value to retrieve. Now, this does mean with dictionaries we cannot have more than one element with the same key. So as soon as we try to add an element with a key that already exists in the dictionary, it simply replaces that value found at that specific key. And so although the values can be duplicated, we could have multiple of the same value, we cannot have multiple of the same key. So this actually provides a different mechanism for getting and setting elements, because again, everything focuses on the dictionary's keys rather than the indices. And that's how we both get and set these items. If we want to retrieve an item, we simply enter the key of the value we want to retrieve, and it will retrieve just the value. It's generally safer to use a dictionary's built-in get function in Python, because this avoids some of the potential errors that could occur. Similarly, setting an item or changing a value in a dictionary is done through the key as well. Now, there's one of two possibilities if we do this, like if we try to set a value in a dictionary. So if the key exists, then the dictionary will find that key, and it will just replace the value at that key with the one that we're trying to set. If that key doesn't exist, then the dictionary will create a new entry with that key and then the value we're trying to assign. So this ensures that it keeps a unique list of all of the keys and that there are no duplicate keys. So you can see a really quick example here. This is kind of pseudocode. I mean, obviously you have to provide real values for the keys and values themselves, but we can see a dictionary is equal to this list of key value pairs. Note the curly braces that denotes that we're dealing with a dictionary rather than a list or tuple. And the keys and values are separated with a colon. So perhaps all the keys could be strings or numbers, or the values again could be strings, numbers, Boolean values, etc. It doesn't really matter too much. If we want to retrieve a value, typically we call upon the dictionary.get, although again we can use the square brackets if we want, it's just a little less safe. We provide the key, and then that returns us the value at that key. If we want to set something, then we actually just use the square brackets. We provide the key that we want to give a value to, and again, if that key exists, then we're going to just replace the value there. If that key doesn't exist, it creates a new key and assigns the value to that. Because we're dealing with keys and not indices, there are actually a whole new set of operations that we can explore, which we will also take a look at in this demo coming right up. So this is going to be much easier to understand if we can actually see it in action, although, dictionaries really aren't too intimidating. If you know how to use lists, then you'll get on fine with dictionaries. Okay, so that's it for this one. Thanks for watching, and we'll see you in the demo portion. What's up, guys? Welcome to the demo portion of our dictionaries tutorial. Here we're going to turn right away to the code and take a look at an example of a dictionary put into play. We'll also explore some of the common operations, guessing and setting, as well as some of the built-in functions. So let's head on over to this old Jupyter notebook. This is again the same collections one. We've got our lists portion and our tuples down here somewhere. Yep, just about there. So let's now talk about dictionaries. So the example that I want to use is going to be a fairly simple one. We essentially want a list of stocks and their prices. I figure a dictionary is a good way to represent this data because we can kind of set up each of the keys as being the stock name and then each of the values as being the current price of that stock. So I think I'm going to go with my big favorite three that we've been using throughout: Apple, Microsoft, and Amazon. And we'll just create that dictionary. So let's call this something like stocks list. And we can call it stocks prices, stocks, maybe stocks dict, just to, differentiate between dictionary and a list. And we'll set it up like this. So we can have a blank dictionary like so, but we'll probably just put some entries in right now. So I think we'll do strings as keys because we're representing the names of the stocks, and then the values will be floats or integers depending on whether a decimal is needed or not. So let's get started. Maybe we'll start with Apple. Again, feel free to use totally different data if you want. I'm just going to give this a key of, I don't know, make up a price, 172.59. Maybe we'll have Microsoft at, let's see, I don't know what a good price for Microsoft is. I think somewhere around 112 is probably pretty realistic. So let's just do 112.23. And for Amazon, oops, let's get rid of that. Okay, there we go. Finally getting that out. Okay, I think it's probably around 1650 at this point, so let's do that. 1650, we'll do like 98 or something. Okay, so pretty cool stuff. We've got our dictionary set up. We've got string keys representing the stock names, and we've got the numerical values, in this case floats, representing the values behind each of those keys. So this dictionary technically has 6 pieces of data in it. 3 different stock names, 3 different stock prices, but each of these pairings is considered to be only one element, okay? So you can recognize the different elements by the commas. If there is a comma, then it starts a new element. Now, the first thing we might want to do is get and set elements. So let's say we want to get our second stock. Let's get Microsoft stock. So we can say something like Microsoft price. Not rice, we want Microsoft price is going to be equal to our stocks dict. And this way we enter the key, so MSFT, and that will print us out the Microsoft stock price. So we can just print out Microsoft price. Okay, cool stuff. So you can see here that the accessing mechanism is actually very, very similar when compared to lists. Okay, we're using again the list name, the square brackets, and in the list case we use the index, but in the dictionary case we use the key. So you can see the order really doesn't matter. I could have this first, this third, this one second, but in a list the order does matter because we access based on index. Okay, so this is just going to return us Microsoft price. Yeah, sure, let's go ahead and run that cell. So you can see 112.23. Similarly, if we wanted to change something, we can do the stocks dict and then enter the key that we want to change. So let's say we want to change actually Amazon's price to something else. Maybe we'll do 170 or 1670.98. Okay, and then if we want to print out that stocks dict, then we should see that it will be different. Now, before I run this, I just want to demonstrate the actual addition of a new element. So what we can do is we can do our stocks dict, and then we can enter a new key that we might not know exists. So regardless of whether or not we know this key exists, we're setting a value to it. And again, if the key does exist, we'll just replace it. If the key doesn't exist, then we create a new entry. That's a nice part about doing this. It doesn't really matter whether or not that key exists. We don't have to do a check or anything like that. We just change the value or assign the value, and the dictionary does the work for us. So let's say we want to add Google's. And I think around this time it's probably trading close to 1100. So let's do, I don't know, 1120.82 or something like this. Okay, and then let's print out our stocks dictionary. So now there's a new entry, Google. So we changed Amazon's price. It's reflecting the new price there. But we also added Google as well. According to this key value pair, and the dictionary saw that it didn't have this key yet, so it created that new entry and placed this value there. With Amazon, however, it knew the key existed, so it just replaced whatever value we assigned. Now, I did mention that it's actually a little bit unsafe to do this. And the reason being because there's no checks to make sure that this key exists. So for example, if I try to print out the stocks dict of something that wasn't there, I don't know, let's just type in some garbage string and try to run that, this is actually going to give us an error which would once again crash your program rather than just returning none or kind of taking care of that error somehow. That's why it's a little safer to use our get method. So if we get something and then we can enter some garbage string, it just returns us none rather than crashing our whole program. Okay, so it's always preferred where possible to use this dictionary.get method rather than just the square brackets. Alright, so apart from this method, let's see what else we can do. So we can run the same things such as the length of our stocks dictionary. And we can also delete an element from our stocks dictionary if we want. So let's say we want to actually delete stocks dict at a specific, not index, but a specific key. So this is where the delete function is a little bit different, in that it's taking in again the key rather than the index. When we ran delete on a list, we just entered the index rather than the key. So let's say we actually decided we don't want Google on there. We want to just get rid of that. So let's just print out our stocks dict, see how it looks after this. Okay, so you can see we've got rid of that. We didn't actually print out the length, did we? So let's just print that out. Actually, this might mess things up a little bit, but let's just do that. And we'll just put this in a new cell. How about that? Oops, and okay, there we go. So let's just run this in a new cell. So you can see we get the length 3. Just works exactly the same as before. Even though there are technically 6 values, it's just counting each of these as being one single element. Alright, so some of the common operations, just going to type them out here, are going to be our pop. We've seen get already, so I'm not going to bother adding that one. We can get items, we can get values, we can get keys. You can clear it to remove everything if you want, but you can also just do something like this, equals an empty dictionary. And let's see if there's anything else. I think that's actually it for the main functions. There are a few more which I don't really find myself using too often, so I'd just like to demonstrate these and then we'll call it a day on this topic. So what pop will do is again just remove an item. So we do have to specify which item we want. So let's say we want to do our stocks dict.pop. We have to enter the key that we want. So in this case, maybe we do want to get rid of Amazon. Let's get rid of Apple. We've seen a whole lot of Apple, so let's get it out of there. But the difference is that this will actually return us the item that it has popped. So in this case, it will return us this tuple right here. So actually, let's continue on with the rest, and then we'll examine that. Items returns us a list of tuples that contains all of the data. So let's just print out our items. So again, stocks dict.items, like so. That's all we need to do. No parameters necessary there. Similarly, if we do the values or the keys, it will return us just those corresponding lists. So if we do values here and keys here. Now watch what happens when we do this. We'll run this and we'll get something kind of interesting. First of all, you can see that this has popped our Apple stock and the price off of our list. It has also returned the value found here. So in this case, it's just 172.59. How about our next 3 ones? So we know at this point our dictionary it only has these 2 elements in it, Microsoft and Amazon, so nothing unusual there. Our dictionary items returns us this list of tuples, but it's wrapped in this dict items object. Same with the dict values and same with the dict keys. So we get the kind of the desired results. So we get the actual values and the actual keys and then the pairings of both of those, but they're wrapped in this annoying object. We can actually solve this problem by doing this. If we wrap each of these in a list like so, then that actually takes care of the problem right there. So we'll do that for this, and let's not forget to balance our brackets out. So if we run this, I think, I totally did not balance my brackets properly. So let's do that, and we'll try again. And let's see what appears to be the problem here. And totally had it right the first time. I think it was just one of those that wasn't balanced. Okay, there we go. So we can see we get the desired result here. We are completely getting rid of this kind of annoying object encasing, and we just get the list that we want. So in this case, we get a list of tuples here. we get the tuple of the key and the value. That's pretty much always what you're going to get. And then we get the list of just the values and then just the keys. So we can get pretty much all of the piece of information we want just from these few functions. Okay, so I think that is just about all we really wanted to cover. We've seen how to set up dictionaries. We've seen that they're incredibly useful when you want to assign values to specific keys rather than to specific indices in a list. I mean, just containing a bunch of prices in a list wouldn't actually be that helpful to us because I don't know which stock these prices correspond to. Having a dictionary makes this much more useful because then we can assign these values to the specific stocks themselves. An alternative and probably a better way in the long run would be to create custom objects representing all this information, but more on that later, that we need to learn a bit more about before we can kind of get into that topic. Alright, so what I'd recommend you do is try this stuff out for yourself, maybe create a new dictionary, try some of these functions out, getting and setting items, getting all the items values or just the keys, and once you're ready to move on, let's actually finish up our collections. I think we have just one more topic to cover. Alright, so thanks for watching, we'll see you guys in the next one. What's up everyone, welcome to the fourth and final portion of our collections topic. Here we're going to be covering matrices or multidimensional lists in Python. This will be quite a short tutorial, as will the demo, as we're really just kind of revisiting old concepts with a slight twist. So what is a matrix? It's essentially a multidimensional list, or as they're referred to in other languages, arrays. So this brings us to essentially a list of lists. So what this means is that each of the elements of an outer list is itself a list. So far we've dealt with lists, tuples, and dictionaries. A list is just a bunch of values stored based on their index. Dictionary was a little bit more advanced. We have basically two values at a single index. So that was the key and then the actual value associated with it. However, with a matrix, we're replacing each of those individual elements with a list itself. So those lists can then contain multiple elements within them. So although this might seem like a fairly intimidating prospect, it's actually quite easy to use. You just have to understand how the inner and outer lists are all structured. Just remember that we're dealing with a list of lists. So when I say the outer list, I mean the overall list containing all of the inner ones. And when I talk about the inner lists, I'm talking about the individual elements of the outer list that are themselves lists. So each of the elements of those is probably just going to be a single value. So what about guessing and setting elements? How does this new challenge change how we get and set elements? Well, unlike dictionaries and much like lists, we access items based on their index. So we're not storing things at specific keys, we're going back to an index-basing system. Again, each of the outer elements is a list itself. Each of the inner list elements is just a single value. So that means if we want to access a whole list, we simply specify an index in our outer list. But if we want a specific and single value from an inner list, we have to specify that inner list's position in the outer list, and then the position of that value we're retrieving in the inner list. Now I know that can sound pretty confusing, especially without the visual aid. It's kind of hard to grasp this concept, so let's take a really quick look at a very simple example here. So I have a matrix, it's just a 3x3 matrix. You can see that there is an outer list, and each of the three elements of the outer list is itself an inner list as well. And each of these inner lists has three elements, so it's basically 3 rows, 3 inner lists of 3 elements each, or 3 columns. So 3 rows, 3 columns, 3 inner lists, 3 elements each. So if we want the very first array, or the very first list, then we can basically just get our matrix at index 0. That's going to return us the entire first list there. So that's going to be that list of 1, 2, 3. Similarly, if we wanted to access the second list, that would be matrix of 1, that would be 4, 5, 6. Matrix of 2 would be 7, 8, and 9. However, if we want to access just one single value, we don't really need the whole list. We have to specify the list's position in the outer list, and then the element's position within that. So let's say we want the very fourth element of this entire matrix. So in our case, as you can see, it will be number 4. Which is in our second list, and it's the first element of the second list. Then we simply get the list's position. In this case, it's at index 1 because it's the second list in the matrix. and then we get the position of the individual element. In this case, we want the 4, which is at index 0 within that list. Alright, so if we want the entire list, we can just access based on regular indexing. But if we want a specific value, we have to specify the index of the list and then the index within that list. So once you have that down, then we can turn to the demo portion of this. We'll just take a look at a really simple example or two, take a look at how to set and get elements from a matrix. And once we're comfortable with that, we can move on to a brand new topic. So as always, thanks for watching. We'll see you guys in the demo. What's up guys, welcome to the demo portion of our matrices tutorial. Here we're just going to set up a really simple matrix and talk about how to get and set various components of it. So let's head on over to our Jupyter notebook. This is the same collections notebook we've been working in the previous few sections. I figure we'll again just bundle all of the collection stuff into this one and start a new one in the next topic. Okay, so we're talking about matrices here. So let's talk about a matrix, which is basically just a multi-dimensional list. Okay, sorry, I'm used to saying array rather than list because in most languages we call them arrays rather than lists, but that's fine. For our purposes, they're essentially the same thing. Okay, so what do we want to do here for our example? Well, I figure what we'll do is just simulate getting multiple data points. Maybe we're doing like 4 weeks worth of data, so this could be like stock prices or something. So I'm essentially going to use for my example 4 weeks worth of price data points. Okay, so I'm going to simulate getting 4 weeks worth of data points, and that will be the price at the end of each day. So that means there's going to be 20 points in total, 5 days in a week, 4 weeks, so 20 points. And I'm just going to pull some really basic prices. These aren't like indicative of any particular stock or anything. I'm just going to use some whole numbers so we can really rush through this quickly. So feel free to add in your own numbers. I'm just going to, as quickly as I can, create a basic matrix here. So I'm just going to call this monthly price data. Okay, and this is just going to be a list of lists. So I'm going to have 4 weeks worth of data, like so. And then I could just enter in some values here. So just going to do like, maybe we'll start 4.5, 4.2. 4.6, maybe we jumped up to 5.1 and then back down to 4.8. Okay, and essentially I'm just going to copy this a little bit to save myself some time here. So let's just get rid of that. We'll put it on a new line and there we go. Okay, so that way just save a bit of time. So we just modify these a bit. Really again, just kind of populating this with totally fake data. All right. So maybe we should make it a little bit more realistic of what it's going to be like. Okay, 4.8, that's fine. Change this to 4.9. Maybe we want to change it up to 5.4. Maybe this will end on a good note. Maybe we went all the way up to 5.9. I'll do 5.7, 5.1, 4.8, and let's do 4.6. Okay, so just really some random numbers up in here. We're going to pretend that this is kind of Mondays, Tuesdays, Wednesday, Thursday, Friday data, and this is going to be the close price at the end of each day. So that's about 4 weeks worth of data. By the way, it doesn't really matter if you put these elements on multiple lines. As long as they are separated with a comma, your compiler will know that this is just talking about the same array of, or the same list of values. Okay, so let's say we wanted the very first week, this week's worth of data. So what I can do is I can access that and store it in a variable if I want. I could say, for example, first week data is going to be equal to my monthly price data, and I'm just going to get the index of 0. So then if I want to print that out, it should just return me my list, no problem. Okay, so as you can see, it's really just the first data point. So we can think again about each of these items, so index 0, 1, 2, and 3, each of those is going to return an entire list of values. So that also opens up my first week data to any list operation that we covered previously. So if we go all the way up to the very top, where are all of our list operations? That should be kind of around, oh no, this is getting into dicts. Here's some operations. For example, we could get the append function or insert, we could get the length, we could delete stuff. these operations all apply to my first week data, which is a list itself, as well as the outer list, so the monthly price data as well. So for example, I could do first week data dot append, and maybe I wanted to append like 5.5, and maybe let's also print it out at the end just to see what it will look like. Okay, to get 5.5 added, no problem. Similarly, if I wanted to get my monthly price data, and I wanted to add something to that, I totally could as well. Probably an array with just some values. Let's just do 1, 2, 3, 4, and 5. Just to show you guys. Oh, and actually I guess we should probably print out the monthly price data. Okay, cool stuff. So you can see we've added that list to the end of it. I guess it ran this append function twice, so now we've got it added twice. Also, one thing I want to point out here, and this is actually more important than you might think it is, this 5.5, which we added up here, has been added to the overall list as well. So although we're adding it specifically just to the first week data, which we pulled from here, okay, and we added that 5.5 to it, it has added it to the original matrix as well. That means it's actually creating a reference to just this list, rather than just copying it and then adding values there. Okay, so that is very important to note, that doing something like this, so assigning this to a variable, is actually creating a reference to this list within our matrix. So if we make any modifications, it will modify the original matrix. Okay? Cool stuff. Alright, so we don't really want these modifications to actually occur. I'm just going to run this cell again, and we'll ignore these two cells for now. Okay, so again, our matrix just looks like this. First week data again is just back to this guy without this appending. This, I guess, appended 5.5. Okay, so we know that we can retrieve items or retrieve entire lists and perform operations on the inner and the outer lists. What if, again, I just want a single value? I don't want the entire list of values. I just want maybe, let's grab this one here, this 4.7. Well, in order to do that, we need to access from our matrix, monthly price data. We need to access a specific row and a specific column. So we need to determine which row we want. I think we wanted this 4.7, so that is 0, 1, and 2. So we're accessing the inner list at index 2. And then we want the elements at index 0 and 1. So that's going to be 1 like this. And then let's just go ahead and print that out. So we should get that 4.7 that we want. That's exactly right. Just remember that we're doing the inner list index and then the index of the element within the list. As long as you don't get those two mixed up, you should be absolutely fine. So the same thing goes for setting elements. Any kind of modification or retrieval functions will work. But if we want to set an element, so let's say we wanted to change this 5.1 to a 5.3. Then again, we get the index of it. So let's get our monthly price data. We want a specific index, and there. So let's say we want this one, which is index 1, because this is 0 and then 1, and then index 0, 1, 2, and 3. So 1 and 3, and we're just going to set that equal to a different number. I think we said 5.3. So let's just print out the monthly price data after that change. Okay, good stuff. So if we run it, then you can see that we have indeed changed at 5.1 to a 5.3. Similarly, you could replace this entire list with something different if you wanted. For that, though, you can basically ignore this part, okay, as you're only accessing one whole list. So let me just demonstrate that actually. Let's create a new cell. Let's just copy that. And so let's say we want to replace, let's replace this entire list of values with something different. So let's say that this is index 0, 1, 2, and 3. And we want to just replace this with values. We'll just increase each of these by 1. 4.9, 5.2, 5.8, and then 6.0. Okay, and then at the end we want to print out our monthly price data. Let's actually just copy that. Okay, good stuff. And we'll run that cell. And as you can see, it's just replaced that entire last list with this new one full of new values. So with that done, I think that's pretty much all we wanted to cover. I didn't want to spend a ton of time on matrices, as this is not the main focus of the next tutorials in the series if you are watching more. I think as far as matrices go, I tend to do a special set of tutorials just on matrices. especially if we start using libraries like NumPy, but it's important that you know how to use multi-dimensional arrays, you're aware of how to set and get elements, and now you do know. Just be sure again, index of the outer array, index of the element within the outer array. If you need to modify one of the entire inner arrays like this, then just use the single base indexing, so basically ignore this. Okay. Otherwise, if you want to access an individual element, then you get the array index and then the index within that array. Okay, so that's it for now. We can finally wrap up our collections and move to the next topic. So thanks for watching. We'll see you guys in that next one. What's up everyone, and welcome to the third topic of our Python language basics. This will be all about control flow. Here we'll take a look at an intro into the concept and dive right into perhaps the most basic form, which is going to be if statements in Python. So what is a control flow from a programming standpoint? Control flow allows us to execute different code depending on the outcome of true or false tests. So that makes it different from what we've been doing previously. Essentially, up until this point, we've done everything from top to bottom and executed every single line as we come across it. Of course, providing that it doesn't crash the program. Control flow allows us to introduce a sense of branching into our code and make decisions based on these true or false tests. It allows us to execute completely different code if the test evaluates to true versus if it evaluates to false. Also, using loops, we can execute the same code many times, but this is again based on the outcome of true or false tests. So this is just kind of a way to introduce logic into our code and decide which parts of the program we want to execute based on maybe events or variable values. So we're going to focus on three major types. We'll take a look first at if statements and their variants. There's actually lots of different minor differences between the kinds of if statements, so we'll probably do a couple of sections on that. And then we'll take a look at while loops and finish up with for loops. So diving right into if statements, what are they and how do we use them? If statements are just used to execute a block of code if a test returns true. They're the most basic form. They simply read if something is equal to true, we'll execute the code within. Using just basic if statements, if that test returns false, we simply ignore the code and move on to the next line of code. Now there are a couple variants. We'll take a look at these first two, the elif and the else statements, and then after this we can take a look at some different kinds. So the else if statement, or elif for short, provides another way to provide another test and possibly execute different code, and that's if all of the previous tests fail. So we only ever pair this with an if statement, so we'd have an if elif pairing. Although we can have an if statement and not an elif, we can't have an elif and not an if statement. So basically the elif statement will provide the second test if the first if statement fails. Otherwise it works exactly the same. The else statement, on the other hand, actually doesn't test anything. It just provides a fail-safe, or a default block of code to execute if everything above it fails. So very often we'll see an if, elif, and else structure with maybe multiple elifs in it. But the else really acts as default, so if every single test above it fails, then we still probably want to execute some code. So this is a really quick example. This is kind of pseudocode. If conditions 0 and 1 were actually like Boolean variables or something, this would actually be real code. But basically, we start off with a simple if statement if something is equal to true. Then we want to execute the code in that first if statement block there. So where it says code here, that first hashtag, that's where we would execute the code. But what if condition 0 evaluates to false? Well, in that case, we don't execute that code, we move on to the next test. That way, we're going to move on to elif test condition 1. If that's equal to true, we execute the code. If that is false, then we move to the else statement. So there's no other tests to test, we just go ahead and execute that code if everything above it fails. One more important point to note here is that if any of the tests evaluate to true and we execute the code, we ignore everything afterwards. So let's say if condition 0 equals true here, we execute the first code block and then skip over the rest. So we miss the elif and the else statements altogether. If the elif statement is equal to true condition 1, but condition 0 is false, then we execute the code block and skip over the else statement. The else statement, on the other hand, is the last possible bit of code that we could execute. So if everything above fails, then we execute it. If any of the above tests pass, then we skip over it. Now, that might have been quite a lot to take in if you've never taken a look at if, else if, and else statements before. So we'll end this section here and turn right to a demo that will allow us to hopefully solidify these concepts a bit better. Like I said, we'll probably do a couple of different demos when it comes to the if statements because it's just too much to jam into one demo. And so, yeah, we'll do two parts. The first one will just cover this if, elif, and else variants, and then the next will cover some more subtle tips and tricks we can use with if statements. Okay, so thanks for watching. We'll see you guys in that first demo. What's up everyone, and welcome to the demo portion of our Intro to Control Flow tutorial. This will be the first of two demos, and here we'll just cover the basic if, else if, and else statement variants. So let's head on over to a new Jupyter notebook. I've got this one started up. It's called Control Flow, and as you can see, it's blank. There's nothing on it. So, what is our goal here? We want to take a look at if, elif, and else statements. Okay, and we're going to use the example of wanting to buy or sell a stock based on the price. So, we want to either buy, sell, or hold a stock based on its price. Okay, so from here, we're going to do just a little bit of setup. We need a stock price variable just to keep track of what the stock's price currently is at. So we'll just do stock price equal to, we'll just do $150. It doesn't really matter which stock we're using. This isn't a real example. This is more just to get you used to the if, else if, and else statements. Okay, so we're going to have a call, or maybe we can call this action, okay, and it's just going to be equal to a blank string. So if the price falls below a certain point, we'll say this is going to be equal to buy. If it's above a certain point, we'll sell. If it's between those 2 points, then we can do a hold call there. Okay, realistically, you probably want to do something more than just have an empty string here. You probably want to actually execute a function that would buy, sell, or hold the stock. But in this case, we haven't really covered extra functions, so we're just going to go with simple strings for now. So to start off with, let's say we're only interested in buying. Basically, if the price maybe goes below 140, then we want to buy. To set that up, we'd start with an if, and then we need the condition to test. In this case, we're testing to see if the stock price is less than or equal to 140. Okay, so what do we want to do if that's the case? Well, we're simply going to set action equal to buy, okay? And at this point, after we execute this, we just want to print out what value action has. So, what do you think is going to happen if we run this particular cell? Well, nothing. Nothing gets printed out except for this blank string. Well, technically that is something, but it's really just an empty string. We don't have anything here. So let's say we wanted to actually give this the default value of hold. Well, we get hold being printed out. The reason this works is because our stock price is not less than or equal to 40. This returns false, so we skip over this code and execute anything after the if statement. However, what if our current price is, we'll do 130. Well, as soon as we run that, we see the buy call. And that's because our stock price is less than or equal to 140. This returns true, and so we do execute this code. I should point out that Python, unlike a lot of other languages, does not use the curly braces. Most of the other languages I've used have used these curly braces in control flow like this. Python is not one of them. It relies solely on colons and indentation. So if you want everything to be a part of this if statement, you have to indent it all. However, my print function call is actually not going to be part of this if statement, so whether or not I want to print this is completely independent of this if statement here, and so I'm not going to indent it like this. Alright, so that's fine, but we haven't really taken account of our sell call. So if the price is less than or equal to 140, we want to buy, but at what point do we want to sell? Well, we can either sell regardless of what the price is as long as it's anything more than 140, or we can kind of introduce this either hold or sell based on the results of a price. So if we don't care what the price is, as long as it's not 140 we want to sell, what we can do is just say else action is equal to sell. Okay, so in this particular case we run this and we still get the buy call. That's because this returns true, so we execute this code. and we skip over all of this. But what if the price is, let's say, 141? Okay, then we go to run the cell, and as you can see, the action is now sell. So this is, by the way, not an elif, this is just an else statement, so it's actually not performing a test. We're just performing the one test. If it's true, we do this. If it's false, we skip this and execute this code here. So in this particular example, we're either buying or selling. If the price is less than 140, we'll buy, otherwise we're going to sell. But that's not exactly what we wanted in the first place. We don't want to just sell if it's more than 140. We want to sell if it's maybe above, let's say, 160. So if it's between 140 and 160, we'll hold, but if it's above 160, we want to sell. Well, for that, we should probably do something like an elif. Our stock price is greater than or equal to 160, then and only then do we want to sell. So an elif statement will perform another test, which is going to return either true or false. So again, this will return either true or false. If it's true, we sell. If it's false, then we simply skip over. So let's say this is let's do, again, 140. Okay, we get buy. If it's maybe 161, we get sell. But what if it is maybe 150? Well, we get hold. Okay, and that's because that's the default action. But what if this was an empty string like this? Well, in that case, we're simply just printing out the empty string, and it's not that great. What we really want to do is assign the action of hold if it is between these two values. So that will give us three distinct cases. If it's above 140, or if it's below 140, we're going to buy. If it's above 160, we're going to sell. If it's any other price, which means it's basically only between those two, then we're going to hold. So in that case, we can do something like an else. We can spell it. Now we can set action equal to hold, like so, and our cycle is complete. So we've got all of the cases accounted for. And because this is a default and we've covered every other possible case, we don't need to say something like elif if the stock price is greater than 140 and less than 160. We can basically just put this in an else call. So now we run it and we get hold being printed out, which is exactly what we'd want. Alright, so we've accomplished our task. We now know how to use if, and else statements, and so we're good to go. So just a few subtle points again. The preceding test cases will only be tested if the following test cases will only be tested if all previous tests fail. So this one won't be tested if this passes, if this returns true and executes this code. Similarly, the else if test acts very much like another if statement, so this won't be executed if this passes. The else again just kind of acts like a failsafe, so if everything prior to it fails, then we need to execute some code regardless. Also, you cannot have either of these two without an if statement, so you always have an if statement first, and then you can do an else if or an else. We don't have to pair the three, we can just have a standalone if statement, or we can have an if and elif statement, or we can have an if and an else statement, or of course the combination of the three as we've seen. And we can even test multiple else ifs. So maybe there's going to be another statement that's saying if it's maybe above 155 we want to buy, but maybe not as many of them. Or I guess we want to sell, but not quite as many stocks. So we can chain a ton of these different elif statements if we really want. It just past a certain point, there's better ways of performing so many tests. But I think you understand the basics of the if, elif, and else statement combo. So as usual, I would strongly encourage you to practice this stuff, especially when it comes to control flow and logic, and when you're not super familiar with how to use it, then I'd highly recommend you practice some of this on your own. So maybe for your homework, before you move on to the next section, try just an if statement, try an if and elif combo, try an if and else statement combo, and then maybe try another one with all three together, perhaps even with some multiple elif tests. And once you're ready to move on, we'll cover the other smaller points that I want to cover with the if statements and the other variants. Okay, so as always, thanks for watching, and we'll see you guys in the next one.